application layer, where the user is going to get the services provided by the devices. Okay, so there is nothing but the functional blocks of IoT. Similarly, we have in another way of representation of these architecture of any IoT system in terms of network layers. Okay, so these are the representation in terms of basic network layers. Okay, so these are called a 5-layer IoT architecture. In some books, they call it as a 4-layer. Okay, so here in the perception layer, where I've got the sensing devices. Okay, it is similar to what I have mentioned in this here. Okay, so this is same as this, but it is in the form of different network layers. Okay, so the physical objects and the sensing devices are there, where they are going to gather the data. Then I have got the network layer, where it's a Wi-Fi, Bluetooth. Okay, how the data is communicated from one device to another. Okay, so there is nothing but data transmission. So the first is data gathering, then data transmission. Okay, so then we do the analytics at the clouds. Okay, so decision unit or data analytics, we call it as a process information. Okay, so there is nothing but my third layer, perception layer, network layer. Okay, and then my middleware. You can compare this with the OSI model. Okay, so in the OS model, in the last layer is the physical layer. So here also the perception layer is nothing but the physical layer itself. Okay, so then there I've got the data link layer, then network layer. So here also the same thing, data transmission. So data transmission through a network. Okay, so we have a network layer. Then in the middleware, we have got the cloud analytics. Okay, so then at the top we have got application layer. So in some books they call it as a 4-layer architecture because they start with the lower layer and they'll end with the physical layer, end with the application layer. Okay, but here one more layer is added, so that's why it is called 5-layer. So in some books they show up to application layer. Okay, so if you show application layer up to application layer, it becomes 4-layer architecture. So this is starting with data gathering, transmission, processing, and then the user application. Okay, so smart applications. Okay, so we call it as application layer or graphic data representation. So on the top of that, we have got the business layer or system management or various business models. Okay, so there is a flow. If you look the same diagram also here also, the perception layer. Okay, so I've got the perception layer, network layer, middle layer, and application layer. So this is similar to what I have mentioned here also. Okay, so in the network layer, I've got different network technologies, how the data is transferred, whether it's a Bluetooth or a Wi-Fi or a Zigbee. Okay, same thing here also I mentioned. At the lower layer as the physical layer, what you call perception layer. So we get the information from the sensing devices. Okay, then in the network layer, we use this network layer in order to send the data to the cloud through a gateway. Okay, so gateway is a part of this network layer. Okay, then in the cloud we have got the processing here. Okay, so CPU is there, storage is there, database is there, and final layer is nothing but the application. Okay, so we have different IoT applications, and then all these application layers are on the top. Okay, top layer. And I'll show. So this is also a 4-stage IoT architecture. Here you won't find the business layer. So in some books they mentioned 4, in some books they mentioned 5. Okay. So this indicates how the information flows from one layer to the another. Something similar to most of the communication through a network follows the OSI layer. It passes from one layer to another. The OSI layer that we have discussed, Open System Interconnection Model. So where I have physical layer, data link layer, network, transport, session layer, presentation, and application. So the 7 layers are there. So most of the communication through a network follows that particular protocols embedded in that layers. Okay. So there it was a 7-layer. So here in IoT we have got a 4 or 5 layer. Okay. Similarly in TCP/IP we have got 4 or 5 layers. Okay. So I'll show that also. So at the bottom layer I've got the physical layer. So physical objects and sensing devices for data gathering. Same thing for data transmission. Okay. Here I've got the gateways or the network technologies, and then processing layers. Okay. So these are the 4 layers process the data on the cloud. So processing unit, data analysis, decision unit, data processing layer, and then finally I've got the application layer. So this you have to remember what are the different layers we have. Okay, so we have perception layer, or we could perception layer, or also called as sensing layer, network layer, data processing layer, and application layer. So we generally call it as perception layer, network layer, middleware layer, and application layer. Okay. So in some books, in perception, they write sensing layer. Okay. So this is how the IoT layered architecture is. In the previous diagram, there is nothing but the overall architecture of the IoT system, but this is a layered architecture in terms of network layers. Okay. So here I have shown the SDN controllers, software defined networks. So nowadays we use this SDN controllers. So we have discussed router. So router is an intelligent device. Okay, because it can store information. Okay, like port ID and network ID. Okay, so wherever the device is starting storing information, so the information are stored, so that added that makes them intelligent. Okay, so in SDN controller, the intelligence from the router has been taken out. Okay, so that is something what you call the brain. Okay, I'll show in the diagram also. For the timing, you just remember that nowadays we use software defined network. Okay, so software is going to control your various network aspects. Okay, so the same rest of the layers remain same. I have got device layer, communication layer through gateway. Then here I have got the SDN controllers. Then at the top I have got the various applications. So this is a layered architecture based on software defined network. Okay, so this is a four layer. So here also the same four layer, but here they are using SDN controller. Okay, in a computing layer. So because starting at the lower layer, the physical layer is nothing but the device layer of all the devices that are connected. And then how the data is transferred from device to the cloud, that is through gateway. So we have network technologies or net communication layer. So you'll find some gateways and the routers. Okay. So this is a representation in terms of SDN, software defined network controllers. Okay. I'll explain what is this SDN. Okay. So IoT communication models, this is something that we have already discussed. There are four communication model: request response. Okay. Public subscriber. Okay. It should be actually publisher and subscriber. Okay. It should be publisher. Okay. Publisher subscribe, push pull and exclusive pair. Okay. So in request response, we have already discussed that we have a client and the server. You send a request and get your information processed as a response from the server to the client. Okay. So this is what I mentioned, what the server does. Okay, server there's something whether you are searching anything in Google or in Amazon, all this follow this model of request response. So publisher subscriber communication model. Okay, so there I've written public. Now it should be publish. So it should be publish. Okay. So publish subscribe communication model. So this is the MQTT is one such example that is used in IoT. Last class we have discussed. So I've got a publisher who publishes data based on the topic, and the broker is a server who's responsible. Broker is responsible for categorizing all those messages that are sent by the publisher under different topics. Okay, and then the subscriber or the consumer, they register and subscribe for a desired topic. So what topics the subscriber are registered for or accessing, the publisher is not bothered about that. Publisher doesn't know what type of topics the consumer is accessing. Publisher's job is just to send the messages. So broker as a service, it segregate all this data into different topics, and the subscriber or the consumer, they'll subscribe and access the data based on the topic for which they'll subscribe. Okay. For instance, if you talk about e-learning, some will subscribe for mathematics, some will subscribe for physics, some for engineering mechanics, like this. Okay. So who is subscribing for what? The publisher is not aware of that. Okay. So publisher job is just to publish, and the server or a broker whose job is to segregate those messages under different topics and then send to the corresponding subscribers. So this is the model that we have discussed, publish subscribe basic model overview. So I've got a publisher, I have got a subscriber, and at the center I've got the broker. So there's a infrastructure how it actually looks like. Okay. So there's one such example. Last class we have discussed customer relation management is a publisher, and we have different subscribers. Some is interested in billing, some is GSI, some is messaging. So then push pull model. Okay, push communication and pull communication. So you push the data in the form of reports, faxes, emails, voicemails, blogs, etc. Okay. Then in pull communication, you get the data. Similarly, what we have discussed in publisher subscriber. Okay. So you push the data into the cloud and you pull the data from the cloud. Okay. So it's called as a push pull communication. So pull is generally used for very large volumes of information. Okay. Where very large audience will be there. For instance, accessing contents on YouTube or any other database or a repository. So huge volume of data is stored. Okay, so used for very large volumes of information. Okay, and this one is uh, a piece of information in the form of blog, mail, or voice. Okay. So in push-pull communication, we have a queue here. Okay, so whatever the data the publisher the publisher is going to put the data into the queue, or the consumer, depending on the requirement, he'll access. Okay. So this queues plays an important role because the data that is published, there are millions of publishers are there. They are going to publish data, and the queues takes the responsibility that the information that is accessed by the subscriber should be in a proper manner. Okay. So if there is no queue, then it becomes very difficult to handle the data. Okay. So that's why the data, this acts as a buffer. You push the data in the buffer, and then from the buffer, it will be sent to the corresponding subscriber. Okay. So that's why messages pulled to queues and messages pulled from queues. Okay, so these are, so you push into the queue and you pull it from the queue. Okay. Then, uh, then we have discussed exclusive pair communication model. So exclusive pair where there is a client and the server. So they'll every time for every message that the client send, they'll get a response, an acknowledgement. Okay, so there's actually synchronous mode of communication, or what we call duplex. Okay, so this is what we call duplex form of communication, where the communication between the client and the server is taking place simultaneously. Send a request, get the response, again send a request, get the response, like this. Okay, so it's a synchronous way of communication that takes place, and the scenario is full duplex. So in half duplex, there is only one way communication. Okay. So this is what today we'll discuss. One is what we call communication API. So API is nothing but what we call application programming interface. So why it is required? For instance, you if you use any app, okay, and that app actually asks you whether you want to share your information, uh, your gallery should be shared or not, or your location can be shared or not. So there various pop-up messages used to come. Okay, so that pop-up messages for different mobile apps. Okay, if you want to install any mobile app, you go to the Play Store and install, and you'll ask various permission whether you will allow your location to be used, whether your data to be used or not. Okay, if you accept it, then you accept, otherwise you click deny. Okay. So what is actually happening is that it is similar to what, for instance, you are going to the restaurant. Okay, and when you're going to the restaurant, the waiter will provide all the services about that particular restaurant. He will give a menu. He will tell you, madam, these are the services are there. Okay, which services you want to avail, what type of food you are going to order. Okay, so from start to the end point, the waiter will be the interactive person. He is going to interact with you. Okay, so you assume that the waiter acts as an interface or an API. Okay, so API is nothing but an interface for communication between two different parties. Okay, whether it's a software API, whether it's a hardware or any application or any function. So API acts as an interface. So in the restaurant, the waiter will act as an interface or an API. Okay, so every day we have plenty of APIs that we use. Okay, for instance, we want uh, uh, weather report. Okay, so Google provides us weather report. So Google doesn't provide us the weather report. provide a weather report by Google is not creating weather report and all. Okay, so it is getting the weather report from any other weather generated resource. Okay, through some API. Okay, so that's why every day we are using plenty of APIs. Okay, API is nothing but application programming interface. Acts as an interface, whether you are interface through some third party to access some data, some file, or some video. Okay, so like this APIs plays an important role in our daily life. Okay, so that's why we call it as an application programming interface. Like waiter acts as an interface when you go to the restaurant. So waiter is the first person who will communicate. You will give a menu. Will when you place an order, he will bring food for you. Then bill. So you are communicating with the waiter. So waiter acts as an interface. Okay. So waiter is directly connected to rest of the resources that are there in the restaurant, but you are not connected. Okay, but you are accessing the resources of that restaurant through waiter itself. So waiter acts as an interface, what you call application programming interface. Okay, so whatever the apps that we use in mobile phone, every app or web app, they have got a lot of APIs. Okay, because API means that API is nothing but a software which acts as an interface. So that will help you to get the information from third party. Okay, so we have two different commonly used APIs. One is REST based communication API and another is WebSocket based communication API. So REST based means what we call it as the representational state transfer. Okay, there is a full form representational state transfer. What it is a set of architecture principle by which you can design web services. Okay, so we can design web services and web APIs that focus on a system resources and how resource states are addressed and transferred. Okay, so that's why I've given an example of web application or mobile apps and all. Okay, so each and every mobile has got their own corresponding APIs. Okay, which will get the information for you. Okay, so that's why it's a set of architecture principle by which you can design web services. So for web services and mobile apps and all, they require APIs. Okay, so in IoT also, so we require a lot of APIs because you are connecting your table lamp or a fan through an internet. So each and every device that you want to connect to the internet must have an identification. Okay, so in Thinkspeak last class probably I've shown that we have write API and read API. Okay, so that acts as an interface between your device and your cloud. Okay, so that's why we use this concept of this model in creation of the APIs because APIs are nothing but a sort of services. So which you can design web services and web APIs that focus on a system resources. Okay, so like Google provide you weather report. So Google is not generating weather report. It has got a tie-up with some third party. Okay, so like this, millions of applications on web apps are there where these web applications act as an interface for you. They are the APIs. Okay, so APIs means they are going to get services from third parties to you. You are not directly connected to the third party. Okay, like your device and the cloud, they are not directly connected. They are connected through the gateway. Okay, so web services and web APIs that focus on a system resources and how resource states are addressed and transferred. Okay, so REST APIs follow the request response communication. You send a request and you get the response from the server. So REST APIs, what are the web APIs that we develop? It is based on this communication model called request response model. Okay, so what are the various architecture constraints we have? It should be a client server. It should be a stateless. Whatever the information that is passed from the client to the server, they are not going to store it anywhere. Okay, so we are not maintaining the state of either the client or the server. So we call it as stateless. Okay, if it is stateful, then you are going to maintain the state of the client and the server. Okay, so when the data is transferred, where it is transferred, at what is the time it's transferred. Okay, so then it is cacheable. So whatever the information in request response, okay, so it can be cached. Okay, if it is not accessed directly, it can be accessed through buffer or a cache. Okay, so it is a layered system. Okay, because the communication between one machine to another, one device to another takes place in a layered form, a layered architecture following various layers of the network. So it also helps you to provide a proper uniform interface. Okay, so that is what it is. It is based on. uniform interface. That's why it's an API. Okay, so it is required for building of APIs and code on demand. Okay, so there are various APIs which will help you to get the code. So based on that code, you can create your own interfaces. Okay. So this is how it looks like, because request response I mentioned here. So I have got the HTTP client where you use a browser based on Mozilla or Firefox or a Chrome, whatever it is. Okay. So in the URL bar, you type https://www.google.com. Okay, so there's nothing but you are using a web browser, and in order to connect your system with the corresponding server of the Google, you are using the protocol called HTTP. Okay, and for that you are using a web browser. So that's why it is called as an HTTP client. So you send a request to the server. So this is my, for instance, this is my Google server, and this is my browser, for instance, Chrome browser that you have opened, and in the URL bar you you type www.google.com. So as soon as you send that particular request, it will directly goes to the Google server. Okay, so yes, so that's why here we call it as a HTTP client. Why it is HTTP client? Because you are communicating through web pages, and that communication is only possible through a protocol called HTTP protocol, Hypertext Transfer Protocol. Okay. So here you see my HTTP request message that you are sending from your browser to your Google server. So there is a so Google has got the web server. We call it a HTTP server. Okay. And so once you are sending a request, it will fetch the desired response and send back to the HTTP client. So this is called HTTP response message. Okay. So all this communication between the client and the server is taking place through the protocol called HTTP protocol. Okay. Over what? Because you are sending from one computer to another computer, so we require the communication takes place. That is nothing but TCP/IP. TCP/IP is nothing but a protocol which is used for communication, web communication. Okay. So I have got HTTP over this TCP/IP layer. Okay. So I'll show what are the layers in TCP/IP, because it's also a part of OSI layer itself. Okay. Transmission control protocol and internet protocol. Okay, so IP means internet protocol, this is transmission control protocol. So you are communicating from one machine to another through your web pages. Okay, so as soon as you type www.google.com, you are sending a request for a web page to the Google server, and then it will send a response. Okay, then you will find an interface where you will find a URL bar where you are going to search something. So then you type whatever you want to search. Again, that request will go from your web page to this Google server, and then it will display what are the list of contents or send different web pages. Okay, so all this is possible because of this HTTP protocol through TCP/IP. Okay, I'll show one more diagram. Probably it is there. Okay. So this is my OSI model that we have already discussed. This 7-layer OSI model, all the connected devices, machines, machine to machine, computer to computer, they all follow this common OSI model. Okay. So since we are communicating through HTTP, okay. So how the web pages are displayed on your screen coming from the Google server. So all this they follow the TCP/IP. So here you see how many layers are there? 5 layers are there. So physical layer, data link layer, network transport, and application layer. Okay, you won't find session and presentation in TCP/IP layer. Okay, so there is a 5 layer. In some books they say 4 layer also. Okay, so network transport application, and both this are combined as one layer called network access. Okay, so we generally follow this 5-layer TCP/IP. Okay, so all this is protocols are nothing but they are the guidelines. So one machine is communicating with another machine, the data has to follow these layers, has to flow through these layers. Okay, so just remember that OSI has got 7 layers. So these are the layers. TCP/IP has got 5 layers. Okay. So at the lower layer, you collect the data. Okay. Then through network and transport layer, you reach to the application layer. Okay. I'll show how it is actually flowed. You see how this is actually how the data is flowing through different layers. So TCP/IP protocol, there are 5 layers. handle data communication. It is very much important if you want to communicate with one machine with another. So you're communicating from your machine to the Google server. That is only possible through internet. So if you're communicating through internet means you're following TCP/IP protocols. Okay. So you see here sending host and receiving host. Okay. So this is, for instance, any application is there, you send the data packets. Okay. So it will go by passing all these layers in different from TCP/IP segment, internet protocol, datagram, frame. So whatever the data that you send, they are nothing but the frames in the network. We call it as packets. Okay. So so all this you will study in detail when you go to the higher semester. I'll just give a general idea. So so these are the layers that will pass. Okay, again from physical layer, again we will go here. Again from physical layer, data link layer, internet layer, transport layer, and application. So his host one. So these are sender and these are receiver. Okay, so sending host and receiving host. Okay, so through some channel. Same thing here also you see data sent by the user. Okay, so the data is sending passing through all the layers through network media, and then data received by the user. So you send a request. Okay, so through network medium you are connected with the Google server and it is sending the response. Again, it is passing through all these layers. So same thing here also shown in terms of OSI layers. So your data is sent by the user, you are sending. So all it is passed through your packets, frames, data, whatever it is all passed through various layers, and then it will reach the Google server. Then from there it will fetches all the web pages and it will pass through all these layers, and you will see the result on your web page. So all this happen instantaneously. Okay, if you have high speed internet connectivity. So this diagram just to explain what are the layers we have and how the data is sent and how it is received. Okay, so we call it a TCP/IP protocols handle data communication. So in case of REST API, the first constraint that I've shown is a client server. So it must be a following a request response architecture. So when I talk about request response means it's a form of client server. So how it actually works? So I have an HTTP client, the same thing I have shown in the figure. Okay, REST aware HTTP client. Then I have an HTTP server. So you are the client here. The Google server is an HTTP server. Okay. So RESTful web service client. Okay, and the REST aware HTTP client. So because it is working on REST architecture on request response model, so I have got an HTTP client, HTTP server, and the server is connected to his own resources. Okay. So here I have got the data that you are sending is generating in the form of packets, HTTP packet, commands, get, put, post. These are all methods. Get method, put method, post, delete. Okay, and then we have a REST payload. Okay, in the form of a JSON or an XML file. Okay, and then it will send the request to the server. It will fetch the desired response, and the response is sent back to the client. Okay, so this is something, it follows the same thing like this: sending host and receiving host, data sent by the user and data received by the user. Okay, so where the data, here I have the corresponding server. That is nothing but an HTTP server. Okay, so this is a bi-directional. Okay, so what is called full duplex. So what is this? Universal resource identifier. Okay, so universal resource identifier has got two things. One is URL and other is URN. Okay, universal resource name, universal resource allocator. Okay, and then we have a universal resource name. Okay, so and URI stands for universal resource identifier. So I'll tell you when I go to the in MS Word, I'll explain all this. But for the time being, you just remember that the communication with REST API, the first one is client server, so it will look like this. Okay. So that is what you call request response model used by REST. So I have got a client, I have a server, establish a connection between the client and the server. Then whatever you want, you send a request. So these are the various requests: get, put, post, delete. get request, put request, update, delete with payload. Payload in the sense that in what form you are getting the response. So it's a JSON or XML. Okay. So JSON is a JavaScript object notation. Okay. So then I have got the response in XML file or in JSON. Okay. So again, you send a request. Again, you get a response. Okay. So in the ThinkSpeaks, probably yesterday I've shown the write API and read API. Okay. So same thing here also. It is happening. Okay. Oh, okay. Section A को दिखाया था शायद. Okay. So these are the various methods and the corresponding actions. Okay. So I got the HTTP request methods and action. HTTP request method, you see get method, collect the universal resource identifier. Okay. So list all resources in a collection. Okay. For instance, you see example how you're going to search. Okay. So I've got get method, I've got post method, create new resource. Okay. So I've got put method. So replace the entire collection with another collection. Okay. So then I have a delete method. All these are nothing but HTTP methods, the services. Okay. Then, so the RESTful web services is web API implemented using HTTP and REST principles. And the RESTful web service is a collection of all resources which are represented by URIs. And RESTful web API has a base. Okay, so this is an example of URI which consisting of both location as well as name. Okay. So client sends request to these URIs using the HTTP methods. So it can service can support various internet media types like JSON. So web circuit we'll discuss in the next class. Okay, let me there. Okay. So because I've used somewhere URI and all. Okay. So there I have written URI. Okay. So in request response communication model. Okay. So there URI is nothing but universal resource identifier. Okay. And this is nothing but URL URN. So universal resource locator. So this is locator and this is name. Okay. So for instance, so just URI, this URI is what it talks about name and address. Okay, so that's why it mentioned URI is nothing but URL plus URN here. Okay. So this is a URL and URN. So both are combined to give URI. Okay, so we call it a resource universal resource identifier. Okay. And how you're going to identify? You can identify by name. Okay, right, www.google.com. So Google is a name. Okay, and the entire, let me give an example. Okay. So full forms are okay. So let me write one such URL. This I'll show in the URL bar also. So if you open your browser on the URL bar, you will find any such, for instance, google.com. Okay, slash some some other information you'll find. Okay, so this entire thing is nothing but URI. Okay, so when you open a browser and you see on the top URL bar, I'll show you. Okay, the entire thing is called as a universal resource identifier. So it's a combination of what? It's a combination of location and name. Okay, so in this so what is a location here? So from here to here, from here to here, it completely acts as URL. Okay, and then if you from, so why it is called a URL? You can note down that it is called as a URL because it follows, it has got the address plus it has got the protocols with HTTP or FTP, file transfer protocol. Okay, so that's why, so since HTTP term is involved, so we have included from here to this, so that is called as URL. So wherever you find URL, you will find this protocol. Okay, so then when I say URN, so URN is just a name, so I can say www onwards, for instance, rest of the, so this is nothing but URN. Why it is URN? Because here google.com is there. Okay, so in URN you won't find this HTTP. Okay, so in URL only you find HTTP. Okay, so this you see, don't get confused. Okay, first you write the complete URL, then if you include HTTP, then it becomes URL. If you neglect HTTP and you start writing from here to here, then it becomes URN. So we call it a universal resource name. So Google is my universal resource name. Okay, so URL always be the complete address with this HTTP, and the complete link is nothing but URI. Okay, let me write here. Okay, so I have URL, I have URN. So this is URI. So that's why URI is nothing but combination of URL and URN. Okay. So that's why I mentioned that my universal resource identifier is nothing but I have name, I have address. So in that URL means only address with HTTP or FTP. So URN just name, by name only, no protocols. So this you have to remember. Okay, because daily you are using all this. Okay, you are opening browser and typing something and all. Okay, so this is what that URI it is mentioned in request response. We require this. Okay, so URL, URN, okay, universal resource identifier. So so in the REST API, the REST APIs are nothing but they are based on request response. So whenever there is a request response, there is a client and the server. Okay, so you send a request, you get a response. Okay, so this so your REST API is working on that uh, client and server model. Okay, so clients are based on client server architecture. Okay, then so what are the other terms that I've used here? Then I've used this API, application programming interface. So we have REST API and WebSocket. This is something that we have discussed here. Okay, so we have discussed especially the client server. Okay, so there I have got the HTTP client and I've got HTTP server. So you send a request. You're sending a request. You are searching something. Want to search something. Then your request is in the form of URI. Okay. Uh, it is also sorry. Then for instance, when I say URL, all URLs will start with, in some books you'll HTTPS, S means secure. Okay, otherwise hypertext transfer protocol. So you write www.google.com. Okay, so this acts as domain and this acts as scheme. So there's a protocol is followed, so that's why it is a scheme. Okay. So generally we have the syntax is, or the representation is, first is scheme. First you write scheme is nothing but type of protocol. Then you write domain www.bitmesa.ac.in like this. Then you find some port number, some path will be there. Then find some question mark. Then you'll find some query string. Then you find some hash fragmented ID like this. Okay, so you'll find different things in the URL. Okay, and so wherever URL means you'll find this scheme HTTP. Okay, so when I say URN, so URN is nothing but you won't find HTTP, only the name. Okay, find ISBN dot some number 9784321, some number you'll find. I'll show you. Okay, so there is nothing but an identifier. Okay, so in some URLs you'll find the strings also. Okay, so there is nothing what you call query string. So what you are searching for. Okay, so you just remember the difference. URL must have HTTP. Okay, the entire string is nothing but URI. Okay, and then URI is nothing but combination of URN plus URL. Okay, so there is a difference. Okay. You see here in the, for instance, where I Google search for BIT Mesra. You know, see here at the top. So this is my URL. See the length. So this is URL for this particular page. Okay, so this particular page has got an identification. So here you see HTTPS is written because there's a security is there. Okay, so then this is my domain. Okay, then you see all the strings, all the text that are coming. Okay, so search question mark. Okay, I've shown that question mark. Then what you are searching for, all this is nothing but the complete address of this page. Okay, so you see all what I have searched BIT plus Mesra, the concatenated string. Okay, so this entire thing is nothing but acts as a URI. Okay, so if you click on any other thing like admissions, it will go to the admission page. Every web page has got his own name and identification and all. Okay, so you see here, so HTTPS W says the domain name. Then I've got the corresponding uh, path. Okay, so admission, then question mark, then the remaining string. Okay, fragmented ID. So as soon as so this entirely thing acts as a URI consisting of URL plus URN. So URN is nothing but the corresponding name SO with, because you are looking for admission. So you see here admissions, and bitmessage.ac.in www is called as a domain. So okay, so if you start with HTTP, it becomes URL. Complete thing is URN. Okay, you start only with www and end with anything, that becomes a name. Okay, so that becomes a URN. Okay. So this is about URL, URN, and URI. Okay. So this is what I have shown in the figure. Okay, so URI, it is mentioned here. So representation resource. So this URI is nothing but that. How you are going to access the pages? Pages are nothing but the information or the resources, whether it's from Amazon, Flipkart, Google, whatever it is. So your request is sending through your web browser, and it requires an internet. So that's why TCP/IP is mandatory. So whatever the request you are sending, you send a request based on some. Your request is sent in the form of this methods, where the get request, put request, post, delete. Okay, and from that particular server, you get the desired response. Okay, so there's a block diagram of communication with REST APIs. Okay, so this is what the communication that I have shown. Get the request, get, and these are the methods that we use in programming. Okay, I have some programmings here. Google App Engine. Java messaging services. So these are generally used in programming. When you write, when you design your web pages and all, then you use this methods in socket programming that we'll discuss. So these are the various HTTP methods, because these methods through web browser, they are activated in order to get the resources from the desired servers. Okay, so that's why resource type you see as a collection URI, element URI. Okay, all are either collect or an element. Okay, but the methods are different. So list all resources in collection, get information about a resource. Okay, so there is a URI that is mentioned here. It's examples.com/API/task, something like that. Okay. So WebSocket we'll discuss in the next class. So if you have any doubt, here also you see I've given an examples. Okay, the first one is HTTP. Here WS it is acts as a schema. Then host is nothing but your domain. Then we have a port number. Okay, so MQTT protocol, 8883 port number. Every server has to run on some port number. Okay, so with reference to the WebSocket, this we'll discuss later. Uh, so this difference we'll discuss when we talk about WebSocket. Okay. Yesterday I've shown you Thinkspeak, right? So we have one like AWS IoT core. Similarly, we have Thinkspeak Cloud. Okay, Thinkspeak Cloud is generally from MathWorks. Okay, or from MATLAB. So MathWorks is a company, and they provide this IoT cloud called Thinkspeak. So it's an open source Internet of Things application. So this is from MathWorks. Okay. So this no. Let me go from this. पासवर्ड एक साथ क्यों नहीं आ रहा इसका? Whether it work or not. Okay. So here this is a IoT cloud provided by MathWorks. Okay. So I've created some channels. Okay. So what we'll do, because just now we talked about API. Okay. So every device must have its own identification, because you're going to connect to the internet, it must have its own identity. So this API key provides an important role as far as identifying these devices are concerned. Okay. So application programming interface keys. Okay. For instance, I'll show one such smart. So you can create your own new channel. So when you create this, when you click that, you can create your own. Okay. So you click on API keys. So in the right hand side here you find this. So this is nothing but my right API key. So you see here some get method is used. Okay. So let me do this. Let me select this. Select this. And I'll open the browser here. And I paste it. So instead of 0, for instance, this is I'm connecting my table lamp. Okay. So I'll type on here. Okay. And let me. So this is my right API key. So what this right API key does, it takes the data from the sensing devices and it will write into the cloud. So that's why it is called write API. So what is read API? You pull the data from the cloud. So you read the contents from the cloud. So there is nothing but read channel feed. So you select this. Okay, now let me copy this and open on another browser like this. Okay. So what I mentioned, so this is my right API. I have mentioned on here. So my bulb is connected to the Thinkspeak Cloud. Okay. So this is the API key of that particular bulb. Okay. Now I press enter. So here you see it is 3. It is mentioned because yesterday probably I have entered 2 more values. Then in the next tab where I want to read from the cloud. Okay. So I press enter. So you see here on I have written, on I have got here. So this is on. So this is a JSON file. So here it is written JSON. You can see in raw data form also. So raw data is this, JSON form is this. So you see a name I've given smart trade, description term demo, when it is created. Okay. So what is the data that is sent from the bulb? On. Okay, so let me switch off the bulb. Okay, so this is actually you have to do using Raspberry Pi, and you have to connect your Raspberry Pi with your laptop or desktop. Then only it will you will understand. Okay, for the time being, I'm just showing what is going to in the cloud and what you're fetching from the cloud. So here I have written off. Okay, now press enter. So at the top left hand corner, you see 4, it is written 4. Okay, so I have written off. It is going from the device to the cloud. Now I'll see what is there, whether it is now here it is on. Now it will become off when I refresh it. See, it is off. So the bulb is off. Okay. So this is nothing but read API and write API. Okay, so write API means write the contents to the cloud. Read API means get the content from the cloud. Okay, so these are the two API keys that we use when you use ThinkSpeak. Similarly, AWS IoT also we use API keys. So these are nothing but the application programming interface. Okay, so this way we call write API. So API request. So API key setting, write API key. Use this key to write data to a channel. Okay, so read API key, use this key to allow other people to view your channel. Okay, so channel is nothing but through cloud. Okay, so like this you can create your own channel. Okay, so I have created many such channels here, my channels. So many channels I have yesterday probably, I don't know whether maybe for other section I have created this channel. Okay, EC bulb. So the more important thing is API. Okay, and the rest we have all data analytics on Dolphin, smart street light and all. So you see here, all these are the analytics, smart parking. So we have written some code for this using ultrasonic sensors. Okay, so all this you see when the bulb is on, when it is off, everything will be stored. Okay, so this is data visualization is also possible. So these are ThinkSpeak Cloud. Okay, so you can create your own channel. So this is possible when you connect your Raspberry Pi with any sensors and you connect that bulb through this ThinkSpeak by using this API keys, because these API keys, this information about the key you have to pass through your program. Okay, so here it's the API key, it is written. So we'll stop here. So anybody having any doubt? So this API is when nowadays without API we can't able to do anything. Everything in your mobile phone has got connected with some API itself. Whether you're using any app, it is we are using through API itself.
Sir,
हाँ,
which language was used in the ThinkSpeak the code?
तो हम तो पाइथन
So
यूज किए हैं.
Python. Okay.
वो मैटलैब के लिए एक्चुअली वो मैटलैब मैथवर्क्स जो मैटलैब का है ना, मैटलैब में भी कर सकते हैं. हम तो पाइथन, हम तो सिर्फ क्लाउड उसका यूज किए हैं ना. सो क्लाउड यूज करने के लिए आई हैव रिटन प्रोग्राम इन पाइथन, सो यू कैन रिटन राइट इन मैटलैब आल्सो.
Okay.
But that services is actually provided by MathWorks. So like AWS provides AWS IoT Core, cloud services, different cloud services. Probably tomorrow or next class after Diwali, I'll show you, because yesterday I've shown to section B, I think. You are in section A, right? You are in
No, sir, we are section B.
so yesterday I have shown to section A. Section A, I have shown how this AWS IoT Core, what are the services. Some services I have shown in cloud computing, that EC2 and S3 and all. Similarly, IoT Core is also one services. Okay, so I'll discuss that in after Diwali. So okay, take care, bye bye. All the best for the quiz. You log in sharp at 6:30. Okay, so even if the page is not displayed, उसको refresh कीजिए या दोबारा login कीजिए. Refresh कीजिए, आ जाना चाहिए, because they are all in the form of images. Okay, so you use your calculator and options will be there. Okay. So happy Diwali to everyone and all the best for the quiz. See you next week. Okay. Okay, so tomorrow I won't take any class. So see you next week. Okay, thank you and bye bye.
Thank you, sir. Same to you.
Thank you,
Okay,
sir.
Thank you, sir.
okay, welcome.